In the words of Johannes Kepler, where there is matter, there is geometry. Now let us know formula for finding distance between any 2 points on a coordinate plane. We know coordinates of origin is 0, 0. Let me take a point on coordinate plane, some p, x, y. Then distance between OP is root of x square plus y square units. OP distance is root of x square plus y square units. Distance between origin and any point on coordinate plane is root of x square plus y square units. If I take 2 points on a coordinate plane, one is A x1 y1 and B x2 y2. A is order pair x1 y1, B is described with order pair x2 y2. Then what is the distance between these 2 points AB? Distance between 2 points on coordinate plane AB is root of x2 minus x1 whole square plus y2 minus y1 whole square. That is square root x2 minus x1 whole square plus y2 minus y1 whole square units. Distance between origin 0, 0, origin O 0, 0 and xy and p xy is root of x square plus y square units. OP distance is root of x square plus y square units. Next, distance between 2 points on Cartesian plane. Distance between 2 points lie on a Cartesian plane is root of x2 minus x1 whole square plus y2 minus y1 whole square. Distance between 2 points A x1 y1 comma B x2 y2 on a coordinate plane is root of x2 minus x1 whole square plus y2 minus y1 whole square units. Distance between these 2 points AB we denote with AB, that is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square units. As there is a square for the difference of x coordinates and there is a square for difference of y coordinates, this difference is always non-negative. This difference also y2 minus y1 whole square also square of this difference y2 minus y1 also non-negative, so that this formula we can write in another manner, that is root of x1 minus x2 whole square plus y1 minus y2 whole square units. Now we have the formula. Distance between 2 points a x1 y1 b x2 y2 is square root x2 minus x1 whole square plus y2 minus y1 whole square units. Let us prove this formula, distance formula. Let us prove the distance between 2 points a x1 y1 b x2 y2 on a coordinate plane is square root x2 minus x1 whole square plus y2 minus y1 whole square units. To get the distance formula, I am taking 2 points on coordinate plane. One is A x1 y1 and the other point B x2 y2. One point is A x1 y1 and the other point is B x2 y2. Here let me join AB. This distance AB we need to find. Here x-axis and y-axis intersecting point is also O. To get the distance formula AB, let us draw a perpendicular from A onto x-axis as AB. Draw a perpendicular from B onto x-axis as BQ. Draw AB perpendicular to x-axis and BQ perpendicular to x-axis. Here given AX1 Y1 as one point on Cartesian plane, and the point is given B x2 y2. To get the distance formula, I drawn AP perpendicular to x-axis and BQ perpendicular to x-axis. Draw AP perpendicular to x-axis, that is x dash OX, and BQ perpendicular to x-axis, that is x dash OX, BQ perpendicular to x dash OX. Next, we know perpendicular distance from x-axis to a point is called y-coordinate. Perpendicular distance from x-axis to a point is called y-coordinate. So that AP length is y1. Perpendicular distance from x-axis to a point is called y-coordinate. So that BQ length is y2 units. So AP is y units, y1 units. AP length is y1 units and BQ length is y2 units. That is y coordinates. Here y coordinate y1 is nothing but length AP. Here BQ is y2, so that y coordinate is y. What about the x coordinate? X coordinate is perpendicular distance from y axis to a point is x coordinate. Perpendicular distance from y axis to this point is x coordinate. On the other hand, to determine the point of the order pair x1 y1, starting from O, we move along x axis x1 units, then vertically y1 units, so that OP length is x1. To determine the point of the order pair x2 y2, to locate the point B of the order pair x2 y2, starting from the origin O, we move along x2 units and then move vertically along y units, so that x2 is nothing but OQ is nothing but x2. OQ length is x2 units. Is very clear? OP length is x1 units and OQ length is x2 units. Then what can you say about PQ? PQ is nothing but OQ minus OP. If we cut OP from OQ, we get PQ. PQ is equal to OQ minus OP. So PQ is a value we know very well. PQ is equal to OQ minus OP. OQ minus OP. So OQ length is x2 units, so that x2 minus OP length is x1 units. x1. So PQ length is x2 minus x1 units. So PQ, now we came to know PQ length is x2 minus x1 units. But here we need to find distance between AB. For this, to find this distance, I am going to do a small construction. Draw AR, draw AR perpendicular to B. Draw AR perpendicular to B. Draw AR perpendicular to B. Small construction. Draw AR perpendicular to BQ. Otherwise, draw AR parallel to PQ. Both sides. Here, by this construction, we can come to know angle P is 90 degree, angle Q is 90 degree, angle R is 90 degree, so that angle A is 90 degree. In this quadrilateral PQRA, every angle is 90 degree, so that this is a rectangle. We can feel it as a rectangle. We can come to know it is a rectangle. PQRA is a rectangle. Clearly, PQ quadrilateral PQRA is a rectangle. We know in rectangle, opposite sides are equal, so that PQ is equal to AR. Therefore, PQ is equal to PQ length is equal to AR. Here, AR and PQ both are of the same length. Opposite sides in a rectangle are parallel and equal, so that PQ length and AR length is same. So PQ is equal to AR, that is equal to x2 minus x1 units. Now we came to know AR is x2 minus x1 units. Here we have, on the other hand, AP and RQ also opposite sides in rectangle PQRA. So opposite sides in a rectangle are parallel and equal, so that AP is equal to RQ. AP is equal to RQ. As AP length is Y1, RQ length also Y1. Its length is RQ length is Y1. Y1 units. That is Y1 units. It is very clear. Now here BQ is Y2 units, RQ is Y1 units. What can you say about BR? BR is very clear. BR is BQ minus RQ. BR, we can write BR as BR is equal to length BR is equal to BQ minus RQ. BQ minus RQ. Actually, BQ length is Y2 units minus RQ length is Y1 units. So BR is Y2 minus Y1 units. So BR place we can write Y2 minus Y1. Y2 minus Y1 units. Now observe here there is a triangle. Here there is a triangle. The triangle is ARB. In triangle ARB, angle R is 90 degrees. So in this triangle it is a right angle triangle, so that we can apply Pythagoras theorem. In triangle ARB, angle B is 90 degree. By Pythagoras theorem, we can write hypotenuse square is equal to side square plus side square. Square of the hypotenuse is equal to sum of the squares of the other two sides. Square of the hypotenuse is equal to sum of the squares of the other two sides. Hypotenuse square is equal to side square plus side square. Here in triangle ARB, hypotenuse is AB, so that AB square is equal to one side is AR square plus another side is RB square. AB square is equal to AR. We have AR length is x2 minus x1 units, so that x2 minus x1 whole square plus RB length is y2 minus y1. So y2 minus y1 whole square. To cancel the square, apply square root. So that AB is equal to plus or minus root of x2 minus x1 whole square plus y2 minus y1 whole square units. Here length of AB is square root x2 minus x1 whole square plus y2 minus y1 whole square units. But here distance is non-negative, so that we write only positive. AB is equal to root of square root of x2 minus x1 whole square plus y2 minus y1 whole square units. Distance between 2 points AB is root of x2 minus x1 whole square plus y2 minus y1 whole square units. So distance between two points lie on a coordinate plane is square root x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula for finding distance between 2 points lie on a coordinate plane.